lead for Incubate Energy Labs. And this really happy to introduce you to this group of panelists today from our 2021 cohort, featuring Community Energy Labs and Southern California Edison. This project is actually still ongoing. They're taking it into the second and third phase. Couldn't be more thrilled. So without further ado, I'm going to turn it over to Tanya Barum, founder and CEO of Community Energy Labs, to take it away and introduce the rest of the group. So Tanya, the floor is yours. Thank you.
Thank you, Annie, and thanks everyone for showing up, especially those of you on the West Coast. Kick the morning off with a webinar. That's how we do these days. My name is Tanya Barum. I'm the CEO of Community Energy Labs, and we're going to be talking a little bit about what is Community Energy Labs, what is the problem we solve, and then specifically why the Incubate Energy Labs project that we did with our host, Southern California Edison. Two of my favorite people from Southern California Edison are on the line today, Anthony James and Mark Martinez. And then we were really excited to work with Min Long, who works on the customer engagement side at EPRI and was really helpful in building the customer engagement piece of this phase of the project. Agatha Kaztan is also on the line from EPRI, and Agatha is in the Smart Buildings program at EPRI, and she and Min are working together to move this project into its second phase, and we'll talk a little bit about that toward the end today. So here are my co-project leaders, some of my, like I said, favorite people. It was a really smart team and a really fun project. You already got the fun meeting logistics, so I'm just going to skip right over that. And first, I'm going to tell you a little bit about Community Energy Labs, sort of outside of Incubate Energy Labs. Who are we? What problem do we solve? And what do we do? And then how does that intersect with the utility industry? So in the same way that Tesla galvanized consumers around a vision for clean, all-electric, self-driving cars, our technology enables clean, all-electric, self-driving buildings. Community Energy Labs has built a software-as-a-service control platform powered by machine learning for building operators who find it complex, frustrating, and very expensive to meet new building energy goals and time-of-use utility prices. Now, this next slide, you are all going to be pretty familiar with because you're part of it, this gestalt. But I want to tell you a little bit about me and my company and the genesis of my company and the folks that work for me. I'm Tanya Barum. I have a long track record guiding transformative energy technologies through the valley of death to commercial success. So I started my career in software and uptime management for large power plants, Navajo Generating System, Colorado Springs Utilities, Tucson Electric Power. And then I moved on to solar PV. And I was employee number 35 later at PECI. That was the nation's first energy conservation program that grew to a $75 million a year, 400-person company and a staple of the energy industry. After 10 years of running my own healthcare technology company, I rejoined PECI again as employee number 2 after they sold to Clear Result and reinvented themselves at the grid edge, doing virtual power plants, microgrids, and working with communities on energy resilience projects in partnership with their utilities. At that time, we won the SEPA, the Smart Electric Power Alliance Visionary of the Year Award for our work with a small rural coal town whose coal plant was shutting down, and we were transitioning them to new jobs in the DER and clean energy economy. All this to say, when it comes to startups with energy management pitches, I feel like I've seen it all. I've invested in and managed those technologies for utilities and at PECI. So what's different between then and now? Well, now there are actual laws, and as you know, time of use utility tariffs that have teeth, and a lot of them. So I started Community Energy Labs because I saw this curve of sort of legislative adoption, this gestalt around what people wanted when the solar and the wireless monitoring industries began to take off in the early 2000s. And I knew the time was right to gather a capable team and apply what I learned navigating this curve to the building energy space. As you know, communities worldwide are pushing buildings to convert to electric, operate efficiently, and consume power when renewables are making it. That's pretty hard. And in addition to passing these tough building performance laws and working for more across the country, this is impacting more than 100 million Americans. More than half of US utilities, many of you on the call, have also introduced time of use rates and demand charges. And for some of these customers, those can be 4 to 10 times more costly and complicated for especially commercial customers to manage. Now, there's a benefit in these time of use prices. They need to happen in order to encourage more renewables integration. But part of the issue is that consumers don't always perceive them that way. So that was one of the things that we addressed in this first phase, was making sure that we understood how consumers perceived this, so that when we rolled out technologies to help with these new pricing, that they understood the rationale from the utilities perspective, from the regulators perspective, et cetera. So let's talk a little bit again about CEL and why this technology is important to customers, and then later how it intersects with the utility. So let's take a look at how this all works at the grassroots. Kim is the superintendent for a K-12 school district in California. In California, you might know that time of use and demand charge rates are now mandatory. By 2017, most customers will be rolling off of legacy rates and they'll be on these new rates. So that price has, that means that now she has to manage time of use charges and demand charges, resulting in some cases, if her energy is poorly managed, in a 40% increase in her energy bills, which is already a pretty big expense for schools. What's more, the school board mandated that all facilities be carbon neutral by 2025. So what are Kim's options? Well, Kim might be spending $3 million per year on energy and demand charges, but building automation that's bundled with upgrades needed to save money costs millions up front. It requires that she pass a bond measure or navigate a lengthy and competitive procurement process. And the extensive install is actually going to disrupt her ability to use the space to feed kids who might be getting 2 warm meals a day at school and provide public services. And without custom programming, actually the systems installed don't reduce carbon or deal with time varying utility prices. So what most middle market commercial customers have is no automation, which means they are literally trying to manage this new world by tracking energy costs in an Excel spreadsheet, and then sending Glenn here or his guys out into the field to try and coordinate hundreds of devices more or less manually. If they have any kind of automation, he still would need to sit in, and this is not a joke, a dusty maintenance closet on a really old PC with something that looks like a Windows 95 interface and manually program individual schedules for every single zone in the building. CEL offers a low-cost, easy-to-install, and simple-to-use interface that Kim can justify on a cost basis, and that Glenn and his staff will be able to use. The nation's K-12 school districts spend more than $6 billion annually on energy. That is more than they spend on computers and textbooks combined. As much as 30% of a district's total energy is used inefficiently or unnecessarily, but managing this increasingly complex expense has been, until now, cumbersome at best. What you're looking at here typifies existing building automation solutions. So if somebody has a tool at all, this would be what they have. I could show you 20 images nearly exactly like this across all of the dominant platforms, and it's always the same thing. This is a product designed by college-educated building engineers for college-educated building engineers. And I love me some college-educated building engineers, but they are not the folks that are operating buildings on behalf of most mid-sized commercial customers. So that's maybe why less than 10% of the commercial building market actually uses any kind of building automation. In most of the commercial market, the people who are running buildings are not college engineers in an air-conditioned room. They have many other responsibilities. The solutions available for them are too expensive, too complex, and create nearly as many problems as they solve. Even something like an Ecobee thermostat might only optimize for one zone. So even though that's a great smart thermostat, it's not optimizing for commercial buildings with lots and lots of individual zones problems. So we interviewed nearly 100 customers, and through this workshop, we did 12 hours of extensive research with 30 individuals across this spectrum. And it revealed that even with nearly a third of the commercial floor space in the US, the public middle market is struggling to keep up with all this complexity. 45% of end users have only a high school diploma. 20% speak English as a second language. Like I said, if you're a school superintendent in California, you might be spending $3 million per year on energy, but if you have to spend even more time trying to get your staff to manage this expense, it's just, they're in a no-win situation. So we wanted to offer something far simpler. Our IoT and software as a service control platform offers quicker energy savings with low upfront cost. Our system orchestrates equipment in real time based on a building owner's preferences and goals, like reducing greenhouse gas or saving money. without having occupants complain about being uncomfortable. So that was another thing we found through these workshops, and we'll talk about that later. Our AI generates a model of how the building should optimally run based on the physical structure of the building, user inputs, and data-derived insights into how a building, equipment, and occupants interact, while also responding to grid or energy pricing signals. In a similar way to how Snapchat makes a quick and dirty model of your face, and then the bunny ears follow your face around the screen, our model predictive control operates the building equipment as close as possible to the optimum in real time. And in doing so, it not only saves users from having to manually adjust building and equipment operation, it actually makes occupants more comfortable, and it saves both time and money. So everybody's happy. Of course, we wanted to point out that all of this that we came up with and was because we saw a problem for end use customers. We coming from utilities, we knew that these prices were not only required but necessary to usher in this new energy future, but we saw the complexity that a lot of customers were facing. And so, we developed this even before the $1.2 trillion Infrastructure Investment and Jobs Act passed. So all of you know that new bill allocates nearly $100 billion earmarked for projects that leverage building electrification, decarbonization, and grid connectivity funding toward schools and publics in particular get quite a lot of attention. So, that's always nice to see that the government is trying to put their money where their mouth is, and we're happy to partner with more utilities to help usher in, mid-sized customers' abilities to participate in this newly interactive grid and decarbonized grid. So I'm not sure why my screen is not, there we go. This is a team with decades of experience scaling software, AI, and wireless systems for energy innovations in the middle market. We've commercialized a national solar schools program, HVAC optimization software, and microgrid controls from R&D to global scale for startups and companies as large as Southern Company. Our team's vision is to grow our emission and affordability impact. According to Project Drawdown and the Crane tool, the adoption of building automation systems like ours has the potential to reduce 7 to 11 gigatons of CO2 equivalent by 2050. Buildings generate 40% of carbon emissions. 70% of that comes from imports of electricity from the grid. Collaboration is in our DNA, thus the title Community Energy Labs. We were incubated and spun out from the nonprofit PECI, Portland Energy Conservation, Inc., as a nimble social enterprise with a suite of grid edge and community-centric IT approaches to climate adaptation, local empowerment, clean energy, and innovation in partnership with utilities. CEL is a certified woman-owned and led energy technology company with a mission to affordably enable communities building decarbonization goals by 2030. In less than 18 months, CEL's core AI-powered clean building control platform was a regional winner of Cleantech Open's International Accelerator, an overall winner in the Madrona Venture Labs Go Vertical Challenge, a U.S. Department of Energy and U.S. Department of Agriculture SBIR awardee, and a California Energy Commission Cal Testbed voucher recipient, as well as participating on 3 of the 12 winning teams for the California Energy Commission EPIC Challenge. Like the other startups in the Incubate Energy Labs cohort, we were chosen from more than 250 international startups by a panel of global utility and subject matter experts for the EPRI Incubate Energy Labs cohort. And we are thrilled to begin working collaboratively with you, EPRI, SCE, and their customers on this project that we know will be and has been of value to utilities and end users. So without further ado, I would like to turn the mic over to my colleague, Min, who will talk a little bit about why EPRI was interested in this project and her program, and take it away, Min.
Thank you, Tanya. I guess back in the beginning of the Incubate Energy Labs program, the reason as the Customer Insights Program at EPRI, why are we interested in not only the technology provided by CEL, but also it's the total domain area. Why we are interested in this type of technology is that we are now seeing more and more interactive opportunities between customers and their utility providers. And on the one hand, we are seeing higher and higher technology adoption penetrations around the DERs on the customer side. And there are also rate structures, more flexible rate structures that are more accurate reflect the cost of on the utility side, and also providing more opportunity for the customer to save. But on the other hand, what does that mean for the customers? It might mean more complicated understanding of their rates, or more needs to understand how their daily actions actually impacting their energy bills. So how can we help the customers to really benefit from these new technologies, these new resources, and also the new opportunities providing from their utility providers? So that's why we are very interested in any technology solutions and engagement strategy solutions to bridge customer and the utility and the technology together. And really, the goal is to making it easier for the customers to really help them to benefit from all those most recent trending development. And if it's going to be an automation, right, if an automation solution, how would you design the automation by understanding more how your daily routine of your customers, so that it would be less intrusive as possible to the customer's daily routine, let them do function their business, operate their business as usual as possible, right? But at the same time, can help them save on their energy bills. So yeah, that's why we are interested in this type of technologies. And with that, I'll hand it back to Tanya to introduce a little bit more about the technology of the solution.
Yeah, thank you. So when we look at, Min is exactly right. When you're looking at a machine learning algorithm, that, you know, one of the benefits is that you want to reduce the amount of time that the customer is spending, you know, doing things that they want to do. You want to automate portions. You need to make sure that you're automating the right portion because they have to trust the robot, right? And so we wanted to confirm with customers that in fact this pain point was real. You know, the utility wanted a proof of concept. We partnered with Southern California Edison. And I had a history actually with Southern California Edison as well, rolling out a large-scale regional program called Air Care Plus, which was a fault diagnostics, rooftop HVAC unit fault diagnostics program and technology for middle market commercial customers. That was back in the early 2000s. So that was fun. I'm sure Mark Martinez can tell you more about that early on. So that was a really cool program that still exists today. But one thing that I really learned is that if you don't start on the customer engagement part first and really do a little bit of customer education and a little reconnaissance about how to approach customers, that they won't really trust the new technology. So we wanted to make sure we did that on this program. So this is a unique solution because unlike traditional DR or DERMS, it does not assume that every customer, even if they have the exact same building systems and controls, will be able to or will be interested in responding to grid signals with the same level of flexibility. It allows customers to state their preferences, and the AI then tries to determine how those preferences interact with the physical systems that are being controlled. So let's take, for example, a situation where we have a small school building with children and teachers. If the preference is to maximize comfort, then the flexibility profile will assume that we have less ability to manipulate heating and cooling set points when rooms are occupied. On the other hand, if we were looking at a cold storage facility, we might have more flexibility with cooling due to thermal mass and less need to address comfort of occupants in a different type of commercial application. So this is super important, right? Because one thing that we found in this workshop was, for example, for emergency load reduction programs or other programs where, for example, there was a cycling of condenser units on HVAC, that was all well and good, and the customer really loved the $500,000 in incentives and savings that they were generating per year, until, of course, they were forced to cycle those condensers for 6 hours in a row on one of the hottest days in June in California, with a bunch of seniors and a high school taking their final exams. So despite how 99% of the time this program worked wonderfully, they quit the program because that one time that it impacted occupant comfort. So we come into this with the machine learning, understanding that customer preferences are really going to be vital, and providing flexibility within the preferences and constraints is really necessary for the sustainability of the solution. So we walked into this project, saying we had a very aggressive timeline, by the way. And this project obviously coincided with the COVID dumpster fire that facilities managers, especially at schools, were enduring. So the schools had gone back into in-person, but then Delta variant came along and Omicron. So that was fun. But still, we managed to bring in K through 12 facilities managers, end users, building occupants, as well as regulators. We had some officials from some of the government regulatory agencies that are trying to push for building decarbonization. And we went through a series of workshops that looked at how do these customers, end users, and building occupants understand what's happening to energy? How do they interact with the management system? Why do they interact with the systems in that way? So, we see a lot of things that don't really necessarily compute logically, like, hey, wait a minute, schools are supposed to be done at 3 o'clock, so they should be the perfect candidate for time of use rates, right? But we're seeing all these spikes at 4 o'clock, 5 o'clock, because the custodian goes in, bypasses all of the room controls, and you get this big heating and cooling spike at like 4 to 5 p.m., as well as lighting as they walk through the rooms. So learning things like that. How does the use of the system coordinate with the customer's other work and operational routines? What are their optimization goals? We know what ours are. If we can communicate a real-time price and we have something that could respond to that, that's all great, but it's only as sustainable as, like the example I was talking about with the HVAC cycling, it's only as sustainable as the number of customers that stay opted in. So what are their goals, and how do their goals differ among different users and differ from the utility? And is there a way we can bridge that gap with technology? And do or would customers make use of this management system to take advantage of their DERs and utility programs if this technology were available? Would they be more likely to engage in a time of use rate, a demand response, or real-time pricing program, or any other DER or emerging technology program if they had automation that they knew could address both their needs and the utilities needs? So that's what we were looking to answer. And so I'm going to turn it over to Anthony James. And Anthony, when you're done, just tell me to advance the slide.
Sure. Thank you, Tanya. So what was really important about these workshops from our perspective was literally partnering and putting customers at the center of the energy transition, which is really important. So Min talked about customer insights. So this is also very important in this part of our decarbonization journey. After the team recruited over 30 customers, there were 12 hours of workshops that focused on educating the customers, building journey maps, identifying gaps and pain points and technologies, programs, and rates. So there were a host of different users and stakeholders, including several school districts in our territory. So when I went to these workshops, what I observed and learned from customers and stakeholders, that it was really important to them that we were listening. This really meant a lot to them. Not just that we were listening, but showing interest in their concerns, their inconveniences, demand charges, need for flexibility, user experience, decision-making challenges, complexities and hindrances, and more, much of which can be found in our team's phase 1 report on the EPRI Incubate website. And as you can see in this slide, everyone's listening very intently to our customers. Can you advance the next slide, please, Tanya? Okay, so as part of what we learned from our workshops, and one of the major pain points is that customers don't feel like they have any insight into their energy consumption or really have any control over their bills. And they're not able to do what we want them to do, which is to consume energy on non-peak periods instead of peak periods. In other words, what we want them to do is to follow the price signals in the rates to optimize the operation of the grid so we can operate it reliably, safely, and affordably. Back to you, Tanya.
Great. Thanks, Anthony. And Anthony was a really great participant too, working on the transmission and distribution data science side, helping us really look at not just, the use cases in the wholesale market side, but distribution capacity side, which is as we more and more, and I don't know how many of you are in communities that are really pushing for electrification, or where you're seeing more electrification of transportation or anticipating it. But Anthony often brought up some of the issues that, of course, are emerging, especially in California, of, circuit capacity at the edge, and how innovations like this with customers that have big enough scale and a lot of electrical end loads, it's very important to address. So thank you, Anthony. What we found was, after going through these, 12 hours of workshops, getting really deep into the technology that they had. So a lot of the screenshots that you're seeing are sort of very interactive. So these were very interactive workshops. There were also deep dives offline with customers, looking at the automation systems they had, asking them, how would you respond if you were to participate in one of these programs? And we used SCE's programs, of course, but these are typical to many of the emerging technology programs that utilities are offering. How likely are you, on a scale of 1 to 5, to participate in one of these programs? We asked that before the workshop. And then later we said, if these programs were bundled with some type of automation, how likely, or analytics and smart controls, how likely would you be to participate? And the willingness to do so increased by, I believe it was about 75%. So this was, like Anthony said, it really was difficult for folks, because they felt that it was too complicated to try to manage this, given the complexity of their buildings and the lack of sophistication in their controls. But they were willing to do it if they had the tools to be able to manage some of that complexity. So I am going to turn it over to our sponsor, Mark Martinez, and let him talk a little bit about his perspective going forward. Uh-oh, it looks like I'm looking at Mark's audio and it doesn't look like he's connected there. So maybe he had a connection issue. Mark, I know some of the points that you wanted to say, because we talked the other day.
I'm going to go back.
There you go.
Can you hear me on the computer now?
Gotcha.
Okay, great. So I apologize for that. I was trying to minimize my bandwidth here. So let me go back to get this thing off of mute. So thank you, Tanya, and really appreciate the folks that are working on this project. Southern California Edison was the sponsor of the Incubate Energy program. And, my department, which is called Emerging Markets and Technology, funded this. There's a quote that I really appreciate when I talk about this type of work, and also the work that Tanya is doing, that said the best way to predict the future is to invent it. And here I think we are really inventing the future for the needs and benefits of our customers. The solution that she's come up with is what I call really curating an optimization for customers. And I've never seen anything quite like it, quite honestly. Rather than just put out the black box and say, here, this is the best thing for you to do, it's actually taking into consideration and moving in with the needs of this particular customer sector, which to me is just an amazing innovation. And that's one of the things that we see so much in Incubate Energy, is the innovation with the partners. And of course, Tanya's enthusiasm for getting the solutions developed and deployed has really brought my department, along with Anthony's group, along, so that we can really move this into more of a dynamic type of rate pilot that we're intending to do. So this is just something that is just, to me, an amazing relationship, and I'm looking forward to continuing that as much as possible.
It's definitely a mutual love fest. We love working with visionary utility partners and also solving problems together. I think that's really the orientation. So one thing, Mark, I don't want to steal your analogy too. I think it's been cool though, how excited SCE is to work with and delight their customers, especially their municipal and public customers, who really get a bad rap, I think, sometimes among technology providers as not being innovative, but I think they want to innovate, but they're very underserved. So I've been really impressed by Mark, Anthony, and the team at SCE. Several of their key account managers actually were also very involved in this project. Just their enthusiasm for working with the customer. Mark, do you want to talk a little bit to what you're seeing on this slide is when we were really starting the, again, very interactive, when we were starting the workshop, we did a survey. We did surveys sometimes in very funny ways and sometimes in less funny ways, but of what kind of equipment and buildings we were working with here. Like, what did they have? What kind of automation did they have on hand? And what this slide says is, if your HVAC were a generation, which one would it be? Like millennials in the workplace and stuff like that. And I think you'd be sort of surprised to find that about half of the HVAC systems in these buildings are out of date. That syncs up well with what we'd read from the Government Accountability Office's report on K through 12 systems that required upgrades in K through 12 buildings. Now think about it, if you are a utility, over half of the equipment in school districts in every neighborhood, in every city, in every town in America are out of date and need upgrading. Now you have a $100 billion cutaways for infrastructure bills, and a lot of this is focusing on HVAC and plumbing for schools. So many of these schools, also ones with decarbonization goals, are looking to upgrade what are probably rooftop units, gas-powered rooftop units for heating, to electric cooling or heat pumps. And what we're seeing in the Pacific Northwest is, as the climate is changing, they're like, hey, while we're upgrading, we didn't even have air conditioning before. Let's add it, or let's add some, new systems to the building. So you're actually seeing these loads, these old loads are going to come offline, and all of a sudden you have this new load profile. So it's getting even more complicated. So in addition to the complications they already have, we've seen in some all-electric schools at 8 a.m. in the morning, a load peak at 8 a.m. that's 5 times as high as the next highest portion of the load in their day. So even with the couple electric buses they have. So we know that this is going to be a difficult transition for everyone, and we wanted to ease that. And Mark, you had a really great analogy about we all know that we're moving to EVs eventually, but what happens if somebody's got a jalopy? And how do we understand how this change would impact them, and what kind of car they're driving now, and if they have range anxiety, and where they're going to go? And so transitioning to a Tesla or an electric car won't be easy. So how do we help them make that transition? I don't know if you want to say more about that, but I thought that was a really great analogy.
And Tanya, I really appreciated the way that you sort of brought more of a sense of identification with this customer group. I've been working with school districts for a long time. I mean, back in the day when we would have lights coming on and we didn't know what was happening, it turned out to be the hamster in the cage in the kindergarten classroom that was triggering the motion sensors. And we've seen how, maintenance is just somewhat deferred. As we say, this customer sector has great credit, but no cash. So the challenge, they have to float bonds to do things, and anything that comes up new becomes a bit of a challenge. So by customizing their needs and interests to reflect what they really wanted out of this, it's really made a big difference. And that's, I think, wish we could make this a delivery channel that would be more broadcast to other departments. But we do that, and as you said, our customer reps really appreciated your interest and enthusiasm for this sector. So just bringing technology to the customer doesn't do it. You have to sort of understand what their needs are, obviously. And Anthony was really eloquent in the way he stated that by looking at the interviews and discussions, the listening mattered. It really does. And so that's something which we really appreciated you facilitating for us. And, I don't know if you're going to talk about the class, one of our educational departments immediately picked up on this, and now they're hosting you to do classes for our customers. So this is really somewhat unexpected from my perspective, since I work on tech, but I really appreciated them doing that as well.
Awesome. Yeah, that was that's a cool next step. That we really, I think what we believe is that technology can bridge the utility and the customer. And like I said, in my 20 years in the energy industry, no new technology. I mean, even the ones that now seem like a foregone conclusion. When I started in grid-tied solar PV, we assumed on the utility side that PV was going to electrocute every lineman in America. Everyone, all of the installers were kind of, old guys with long ponytails that had been doing off the grid systems. It was a totally different world. Building inspectors were like, what do I do with this thing? And so there was this whole education component. So I did think that was very visionary of SCE. They have an energy education center, which provides a lot of education to HVAC technicians, architects, contractors around energy. And so, yes, on April 12th and 13th, SCE is hosting the same workshop that we did through the EPRI Incubate Energy Labs for their commercial customers. And I think there are 60 folks enrolled. So it was very popular on grid interactive, efficient building controls. And we may offer that again in the future. I don't know that I personally will be the one teaching it in the future, but it really was quite popular. And I think that SCE's education group, which is completely separate from Mark's group, really saw the value in introducing this and doing that market transformation for their customers. So, okay, so we've talked a lot about this cool project. I'd like to turn it over to Agatha from EPRI to talk about what's next.
Thanks, Tanya. It's so great to hear about this project and all the awesome learnings from it. It seems like it was just a great experience for all. I wanted to talk a little bit about how EPRI is sort of enabling a phase 2 of this. And for those of you that are interested in getting more involved, here are some options. So there's sort of two efforts in development. For studying smart grid interactive building controls, mostly focused on non-residential customers. One is an active supplemental. The Commercial Buildings Interest Group is a knowledge sharing forum for discussing building flexibility and enabling technologies, and for studying best practices for building operators and owners and utilities and how they may coordinate on-site distributed energy resources and demand response in a flexible way for grid benefit. And then there's another initiative that Min and I are working on, which is scoping field demonstrations for different building types, where we'll be studying two things primarily. We'll be studying the utility value proposition for demand reduction and load flexibility, as well as the customer value proposition for emerging utility tariffs, energy savings, lower carbon, upfront costs, faster returns compared to incumbent building automation and control systems. So these are two sort of immediate ways to get involved. You see the link there for the supplemental. You can reach out to me for that as well. And then if you're interested in getting involved with some of our field demonstrations, please reach out to me or Min as well. So thanks a lot. We're excited to keep going with this effort, and Community Energy Labs, of course, will be one of the technologies that we test. So thanks a lot.
I just put that link to the supplemental in the chat for everyone who is interested. And as you can see down there, Agatha, Min, and Sarah Biani are all working on that field demonstration supplemental. So any of those folks, I'm sure, would be available to talk to you. So with that, I think we have a little bit of time left for Q&A, right? Angie, is that true?
Yeah, we've got about 20 minutes here, so feel free to field your questions for the group, folks.
I know it can be easy to sort of do your taxes while running these webinars. So if folks want to turn your cameras on, I'd love to see your faces. I always love, it's like the little squares, the little Hollywood squares. So if folks want to turn your cameras back on, I would so appreciate seeing your faces. And it looks like Peter has his hand up, so I'd love to hear from you, Peter.
Hi, good morning. Peter Milberg from Ameren, Illinois. You're going to have to update that one slide because Illinois just last fall passed some very wide-ranging and deep energy legislation to move us to carbon-free generation by 2050. Question I had is, as I'm listening to this, it almost sounds like what you're talking about is kind of a blend of the old-fashioned listening, but then also that next step of listening, but then using these tools to basically put on their cell phones, essentially the ability to control buildings. Am I getting that right? And then am I making it too simple on that second half of what happens after you listen, what you do with customers?
Of course, it's a simplification, but I think we need to simplify in order to understand the technology behind the scenes. And I have to be careful because sometimes I just want to get so deep into it. This technology, this product was funded by the Department of Energy through an SBIR, and then through some paid pilots and contracts with, for example, I think I mentioned that I started the Bonneville Environmental Foundation Solar for Our Schools program back in the early 2000s. That program is now an education and market transformation program around energy systems, and it's an emerging technology program. So they funded some of that work too. What the technology does. So yes, good old fashioned listening and user experience, but we're also listening for some very particular things, because the truth about machine learning is it's not very smart. So, we see these movies like Ex Machina and we're like, oh, the AI is gonna, AI is like your standard toddler. I mean, they're pretty smart, but it really is sort of often very dependent on the data. So AI should be used not to do things like determine who we talk to on social media, because that clearly has very bad consequences. But the perfect application for AI is things like turning fans on and off. So, something a toddler might enjoy doing, right? So the problem is that you have to be very clear. With a toddler, you can't give them lots and lots of complex instructions. So part of this listening is determining which feature sets we use in our data pipeline in order to enable that machine learning to function properly. So there's sort of a couple things, and there's a slide I might go back to if you don't mind. And again, I would really encourage folks, I want to see, thank you, by the way. I should just say, thank you, Peter, and thank you, Annalise, so I can actually see your faces, and Anthony, I love it. Let me find this slide and I'll show you sort of what our questions are helping us understand. If we look at different tariffs and load shapes, we have no idea what is driving those. And frankly, neither does the customer. So we wanted to get in and find out, like, okay, this is some combination of, like I hinted before, a need that they have for comfort, a constraint that they have, like all of our temperature set bands, literally one district in SDE's territory, their temperature comfort set bands, this is not a joke, are 70 to 72 degrees. So, understanding what their stated preferences are, what choice paths we have, and we would call those constraints in our optimization algorithm, what data pipelines we have and how clean that data is so we can determine our feature set for the algorithm, and then determining recipes for algorithms that will work. So within this use case, what algorithm can we apply in order to meet their stated objectives given the physical constraints or other constraints that they have on the system? So the good old-fashioned listening is, in fact, a little bit of a sneaky way to figure out which of our algorithms will apply to which use cases under which constraints, and find a scalable way to apply those. And we now know that we do have scalable ways to do that. So one of the algorithms that we'll be applying in the state of California, for example, is California is requiring day-ahead real-time rates be tested in the field with real customers. So we have 4 projects in development that will be starting this May through June, where we will be responding to a day-ahead real-time rate forecast for, what are, and I don't want to say unsophisticated in a negative way, I would say leanly staffed commercial customers. So when we talk to the key account managers who really love their customers in this segment, they were like, real-time, they will never be able to do real-time rates, never. It is too complicated. What they meant was, with the technology that they currently have, they will never be able to manage those rates. So we are actually piloting the automation that responds within those constraints using the systems that they have on site to a day ahead real-time rate. And we'll have some more to share on that early next year. We're also doing a pilot with Lawrence Berkeley National Labs and University of California, Berkeley Center for the Built Environment on several schools that will be looking at automation of reducing demand charges for, like I mentioned to you, the school districts that, because of heating and cooling, have that massive spike. We anticipate that we will be able to reduce coincident peak demand within these commercial buildings by at least 20 to 40%. So that's another algorithm that we're working on right now.
Thank
Tanya,
you.
can I add something with regard to, to help with some of the things? And there was a project that Anthony did, and he looked at commercial buildings that were all on one circuit. They were all in the same rate. They all had similar building characteristics, but they all had totally different load profiles. And this reflects the fact that one building had real estate people, another building had attorneys that were different hours and things like this. And so the question was that Anthony came to us with is, why aren't these people all following the time of use rate that they've been given? And it's basically because they all have different operating needs and characteristics. So this is why your project is so important, to be able to customize the needs of the customer in accordance with the needs of the utility for grid reliability and affordability. So that was something that Anthony, that's why he's part of this team. He's over in T&D, but this is really important because he provides the insight from the grid side.
Thank you. I was going to make a comment and then ask another question if I could. And I see that you posted the link to the dynamic rate pilot in the chat. Thank you. I appreciate that. In Illinois, we've had a program called Power Smart Pricing, and you talk about unsophisticated customers. Been using hourly rates with residential customers since 2006, something like that. Switched to day ahead rates somewhere around 2012, something along those lines.
Wow.
Because our administrator was telling us that was a barrier to participation because people didn't know, so now they know the day ahead.
Right.
But you just talked about that next step that we have yet to have anyone come up with, and that is taking that and using that information in an automated fashion to basically set it and forget it with regard to customers' thermostats, HVAC systems,
Yeah.
So I will tell you that our learning is that unsophisticated customers can use these tools. They do save, once they understand what's going on. There's different things you can do, to help educate them. But that next step is what, we've always been scratching our head about. It's kind of the secret sauce. So I do want to learn more about that, the automation to respond to the day ahead. For the utilities, can you talk about the staffing impact? I mean, one of the things that listening, to individual customers involved. I mean, there's no way around this. And I wasn't being disparaging, but that old-fashioned approach of listening requires people to actually do the listening. So can you talk to me about staffing impacts? If there were any, did you have to staff up? One of the outgrowths of this legislation in Illinois is, excuse me, we have to get customer input into our planning processes, the actual distribution system planning. And so we're trying to figure out how to meld that with our energy efficiency outreach that we're already doing pretty good on, but then also incorporating that. And it sounds very similar to what you're going through. And we're trying to figure out how to staff it and how to appropriately staff it. So any comments from the utility side in terms of impact on staffing and any constraints you experience as a result of this effort?
So if I may add, so in terms of staffing for this pilot, I attended workshops. A lot of the insights were gathered by, Tanya. What I might recommend is the format of the workshops is pretty good format that could be used, and maybe there might be some additional work that could be done where it is a format that is sort of broadcasted to as many customers as really you might need to. Again, the workshop would need to be augmented quite a bit such that you could actually get the learnings and educate the customers, remotely, like what we've been doing for the last 2 years, and then to be able to then solicit their feedback, and then aggregate and summarize the results. And I would envision that the surveying that you might do might be in such a way so it's not open-ended, open questions, but asking for very specific information, such that you're actually able to aggregate all that information. And I think the real benefit of doing that is the customer market is very segmented. I mean, very fractured. And so if my thoughts are, if you're able to actually segment customers by rates, by customer type, then you'll be able to kind of aggregate by those groups to really hone in on, what are those needs and pain points for those specific groups, and then how they could be addressed.
Did you do all this remotely via, technology like we're using today, or were there actually in-person meetings?
There was not a single in-person meeting. I will say too, we did hire a user experience researcher who did a lot of the day-to-day, someone who worked for Community Energy Labs, who did a lot of the sort of off one-on-one. So you see her here with several building operators and energy managers. But as Anthony said, we used standardized tools and surveys. Now they were very interactive. So, we didn't just go in there and say, hey, tell us about your day. There was usually a frame or a context, though we did get a lot of free ranging input, and we recorded and transcribed those meetings, you can see here that this particular discussion was, how can you reduce the cost of energy in a typical day? And what preceded that was there was a board that they would interact with where they would anticipate, how do you use energy in your building throughout the day? What systems and loads do you predict are creating this? And then how would you move that around under a time of use? This red is like a time of use situation. You can see in another slide, they're looking at a demand charge. In other slides, they would look at the timing of renewable energy and they would move it around. And then we had a number of interactive tools too with groups and teams that presented lots of different technology, policy, and other types of choices. And like Anthony said, we were gathering all of this in real time with people on the call. So we had the tool there ready to gather the information, and then they would break out into breakout rooms. I think right now with SDE's Education Center, the biggest limitation is really just how many breakout rooms can we have in order to have somebody manning the tech to capture the data. But it's 8 hours. That one is 8 hours. We've reduced the workshop time to 8 hours, which I think should be fine. And it's a curriculum that we've already developed through this workshop and others. So I think it could be repeated, and I'd be happy to share what we did.
Okay, thank you very much. Appreciate it. Yeah, coming from the perspective of someone who is happy that he can operate the mute and video button successfully, this whole having someone else operate the technology during a workshop thing is a good idea. So thank you.
That awkward pause when you have 6 minutes left. Is there any other questions and comments? Nice to see your face, Annalise. Did you have anything you wanted to say? No. I'd be really interested to hear from anyone who hasn't spoken up or asked a question, just like it was really interesting to hear Peter's feedback. What is just your impression of this type of a project? I see Jason from Caribbean Utilities, Michael, Shelby, Alan.
This is Agatha. I'll just, while there's a little silent time, I was wondering, so how did some of the kind of feedback and data that you collected through these workshops sort of inform or validate or, negate the solution that, CEL is kind of bringing to the table in terms of its control technology?
Oh, that it is such a good question, and I want to show one of the boards. I felt, for us, we had actually done before we started our company. As I mentioned before, I'd worked in the sector for a long time. Furthermore, we had done like 100 customer validation calls through NSF core, so we thought we really knew the purchasing behaviors, the problems, how to solve it. But once we started doing these deep dives, it really gave us ideas for several other machine learning algorithms and optimization routines that would really help these customers just with serious problems that they have. Also some very basic innovations. So I'm going to show my screen again in just a sec. There were some things that I just didn't even realize how bad it was. So what we said to the customers was, hey, we think this is the kind of interface that you're working with in your control systems, if you have them at all. And their answer to us was, no, it's way worse. it's way worse than what you think. So here's one thing that we heard from an energy manager at a fairly sophisticated school district. So this is just one of the workshops that we did. We gave them 2 scenarios. The first scenario is that an occupant has a comfort. Most of these schools do have central policies, but then customers will complain that they're not comfortable during times when the school is trying to save energy. So we walked through what steps would you take to ameliorate that comfort complaint. And, you're looking at real screenshots from these customers' systems, like Windows 95 called and it wants its interface back. And just managing this was such a hassle. Some of these energy managers said that they spend a full day a week rescheduling their automation systems. Furthermore, they're like, I can't even do a simple search and just find the equipment that I want. So some of the innovations that we did were just incredibly simple in our user interfaces, so that when you go in and you search, all you need to do is like search for your school and boom, there it is. Immediately you get everything that you need right there. And it's going to take a minute to sort of populate on my screen right now, but boom, you've got it all. And so it was just, there were some things like that I think we made it, they didn't even need complex solutions. Just what they have is so difficult to use. That was an interesting insight for us.
Yeah.
All right. Well, thank you all so very much for this great work. It's been just an awesome it was an awesome cohort last year. It was an awesome project, great team. Really excited to see what comes next, and this just continued great effort as this thing continues in California and beyond. And Peter, I encourage you to get in touch with Tanya and the team for using this in Illinois, because I think they're onto something here, big time. So, and as an aside, Ameren was following this closely last year as well. So Travis Herman was the gentleman at Ameren who you should talk to. I know Travis and Tanya had conversations multiple times. So with that, we will be getting this presentation out and the recording out to everybody on the line today as soon as it's available. So thank you all for tuning in today, and we encourage you to keep following us into the future, and hope everybody has a good and safe day, and we'll see you next time.